Okay, so hi, Mr. T here. I just want to go over the video here on what I say, the video looking at momentum in two dimensions. Okay, now I've got that out, let's see if I can answer the questions. Okay, so momentum in two dimensions. So we've got an example here. Here's a problem. We've said that we've got a metal disc on a frictionless track. It's moving, it has 0.065 kilograms or 65 grams, and it's moving at 1.8 meters per second across the table. It hits another metal disc of the same mass, which is stationary. So, well, let's draw this. So I'm going to draw these two discs. Okay, so one, here it is moving towards the other, although we set it 0.065 kgs. I'm going to call this A just to clarify things. And then we've got B over here, and it's stationary. So it's also 0.065 kgs, but the first one is moving at 1.8 meters per second negative 1, and this one is 0 meters per second negative 1, right? So this is before. But they're going to collide, and then after the collision, it says, okay, so this is after, that what's going to happen is A is going to move away at a different direction to B, okay? So here's A, and B, here's B, but A is moving at 1.1 meters per second. And these two are at right angles to each other. So this is really important, the right angle thing. And the question asks us, can we find the velocity of B, of the second disk, of B after the collision? Now there's one underlying key concept to this whole problem, and it's what makes it reasonably tricky. And the key concept is that for a start, A had a momentum, and I can work out the momentum of A. Okay, so momentum of A equals M times V. Okay, this is momentum of A in, let's say before, equals M times V, equals 1.8 times 0.65. Sorry. Let's get this right, 0.065. Okay, let's get this handy dandy calculator out of here, and calculator, sweet, here it is. Okay, so 1.8 times 0.065, oh sorry, 65 equals 0.117. Okay, equals 0.117 kilograms meters per second. Okay, so this is the momentum of this for a start of A. It's moving in this direction at 0.117 kilograms meters per second. Okay, so what is its momentum afterwards? Well, let's work out the momentum of A afterwards. So the momentum of A after, or sorry, let's say the momentum of A after, yep, that's all right, equals 1.1 times 0.065. And when we times 1.1 times 0.65, we get 0.0715. Okay, kilograms meters per second. I'm just going to leave that out because I'm running out of room there. Now here's the key concept of this problem. A started with 0.117 kilograms meters per second to the right. Now it has 0.0715 meters per second. It had a change in momentum. The change in momentum that A had is equal and opposite to the change in momentum B had. Because where did the momentum in A come from? It can't get it from anywhere. It just can't get it from nowhere. And overall, there has to be no change in momentum. So if A changes its momentum, there has to be an equal and opposite change in momentum from B. So here's the key underpinning idea to answering this question. And that is that the change in the momentum of A, okay, so the change in A's momentum is going to equal to the change in B's momentum. Apart from, PB. Apart from it's going to be in the opposite direction. Like the line's going to be in the same, it's going to show in the same way, the arrowhead's going to be on the other side. These two have to be opposite. Okay, Newton's third law. If you change the momentum to, if you've got two things in a situation, and one, the momentum changes in one, the equal and opposite momentum must change in the other. So, now we get to solve the problem, because if we want to find the change in momentum of B, that would be its actual momentum because it was zero momentum for a start. So to do that, we just need to find the change in momentum of A. And the change in momentum of A, because it's the change in momentum, equals the final momentum of A, or what we would say the after momentum, minus the initial momentum of A, or the beginning, right? And, well, the after momentum of A we've got here. Well, actually, let's just go over this equation. Let's rewrite this equation. The change in momentum of A equals momentum of A after plus the negative momentum of A before. Interesting, that. The funny rules of maths, but if you add a plus and a minus together, you get a minus. So I can rewrite this minus as, if I add two vectors together, the positive after momentum vector for A and the negative of the before vector for B, then I can actually find the answer of the change in momentum. Now I want you to look at this here. If this is the positive, then the negative is this. It's still the same size, it's just going in the other way. This is negative the momentum of A before. So now what I'm going to do is I'm going to add the momentum afterwards. So let's do that. Here's the momentum of A afterwards. Yep. So this is the PA afterwards. And I'm going to add the negative of PA before. Yep. Because I add those two together, tip to tail, and then my resulting, or my answer is the resultant of those two, which is going to be starting here and finishing here. This is my answer. And remember, my answer is equal to change in A, or this is equal to the change in momentum of A. Okay? And I know the values for these two. So I know that the value for the momentum of A, sorry, that's negative. The momentum for this is the magnitude is still 0.117. And I know that the magnitude of this is 0.715. So I'm just going to solve this answer to find out what the change in A is using Pythagoras' theorem. And so what I want to find out is one of the shorter sides. I know this is the hypotenuse because this is a right angle. Okay, I know that's true because this is the after momentum of A, and this is the change, which is equal to the momentum in B in the direction it's going, but it's the opposite direction. So that's a right angle. So now what I'm going to do is I'm going to go, okay, well, what is the change in P in A? It equals the square root of the negative P, negative P AB, yeah, squared, minus the square root of PAA, yeah, the square of PAA. So that equals the square root of 0.117 minus squared minus 0.0715 squared. Let me just go back and change that there. Okay, and then I find this answer. So I get my calculator out of here, and so I put in what 0.17. Oh, sorry, 117. Let me just square that. Plus, oh sorry, minus 0.0715 squared equals, and I want to find the square root of that. And the answer here is 0.926 equals 0.0926 kilograms meters -1. That's the answer for this. And remember, I said that delta PA equals negative delta PB, and delta PB just equals PB after. So this is the answer. This is the magnitude of my answer. It's just going in the opposite direction. We can see that it's going downwards, but in the opposite direction. Now, if we want to find the actual angle that B is moving off, which we would have to do, is we want to find this angle here. And remember, B is going to be moving in the opposite direction, so it's going to be moving down here, and we find that angle. Now, if we want to find that angle, we should start with the data that we had for this and this, which is the hypotenuse and the opposite, and that means sine. And so I'm going to go that the theta, or the angle, equals the inverse of sine, okay, times the opposite over the hypotenuse, which is 0.01715 over 0.117. Now let's see if I can do this on Microsoft's calculator, which sometimes can be a bit of a pig. Here it goes. So let's try this. Okay, let's do what's in the brackets first. So 0.01715. Wait a minute. 1715 divide 0.117 equals, and then I want to do the inverse sine of that. And the answer is 8 degrees. This is so wrong. I'm feeling so bad here at the moment. What have I done wrong? Oh, right, it's 715. Let's do that again. What a major mistake. So when you get something that's kind of out of the box and you think, well, there's no way that's the answer, go back and see what you did wrong. We saw what I did wrong then. So let's do that again. 0.715 divide 0.117 equals, and now we're going to do the inverse sine of that, 37. That sounds like a good angle. So this angle here is 37 point, come back calculator, come back. It's gone. Okay, so it was 37 point something. You saw it, you know that it was right. 37 degrees. It might have been 37.8, it might be 38 degrees, right? So in order to give the answer here, oh, sorry, I've got to calculate the velocity. So I'm going to take this momentum, I'm going to divide it by the mass, and that'll give me the velocity, but I also have to give a direction. Okay? And that is how we solve that problem. It's quite a complex problem, but it's fun to solve. Okay, that's it. I'll see you the next time on my next video.